Hi guys, welcome back. We're going to talk about rates, ratios, and proportions today. So we will hop into those. So just kind of a review, a ratio is just a comparison of two quantities by division. So a lot of times that'll look like a fraction. Sometimes we'll put it as like 3/5, something like that with our little colon there in between, okay, or like a 3/5. Those are all ratios, okay? We're just comparing two numbers. A proportion is a statement that ratios are equivalent. So a proportion would be saying two fractions are equal to each other. So like 3/4 equals x over 20. Two fractions equal to each other, and we can solve for x in that case. Okay? Or maybe like we could say 3/4 is equal to 15/20, right? And then a unit rate is just where the second quantity in your comparison is the unit of one. So like 17 miles to 1 gallon. Or we could say we're driving 50 miles per 1 hour, okay? Or maybe we are dumping 2 teaspoons every second, okay? So the second quantity is always a 1. Sometimes we say, you get $5 for one bag of apples kind of deal. Okay, so the second quantity is always 1. So let's use these to convert to some things. So it says the ratio of faculty members to students at a college is 1:15. There are 675 students. How many faculty members are there? So we're going to set up a proportion to solve for this. What's nice is sometimes we're able to figure it out and be like, oh, do I multiply, do I divide? You're able to get this immediately. But if you're not, set up a proportion. Anytime we see 3 different numbers, a lot of times this is when we set up a proportion. So 1:15. So that means we have 1 faculty for every 15 students. And we want to know when we have 675 students, okay, how many faculty are there? So notice I had 1 faculty goes with X faculty and 15 students goes with 675 students. And then these two numbers go together because it's 1 faculty per 15 students. We're trying to figure out how many faculty go with 675 students, okay? So I'm just going to get rid of my extra letters here because that was just kind of helping me arrange some things. And now I can use my butterfly method that we kind of learned in 7th grade. So we can multiply the diagonals when fractions are equal. So 1 times 675 equals x times 15. Okay, which some of us are going to go ahead and jump right to 675 equals 15x, and that's totally fine. And then we're going to go ahead and solve for x, divide by 15. Okay, and 675 divided by 15 would give me 45. And we are going to be very, very particular about our units in this chapter, okay? So please, please, please make sure we go ahead and put a unit on this. So this would be 45 faculty. Okay, so on your test, okay, I'm going to give you a point for putting the proper unit. So even if you have no idea how to do the problem, but you know what the unit's supposed to be, you can go ahead and write that and get a freebie point, okay? All right, so this next one, Gabe at 8, I can't type apparently, 53.5 hot dogs in 12 minutes to win a contest. We want to find the unit rate of hot dogs per minute, okay? We could set up a proportion for this one, but some people are going to be like, Miss Hawes, I know to do 53.5 divided by 12, and that gets it for me. That's absolutely fine. So if we did set up a proportion, we'd have 53.5 hot dogs in 12 minutes would equal x over 1 minute, because we want to know the unit rate, which means we want to know that the second quantity, which is minutes, is 1. Okay, so 53.5 times 1 is just 53.5 is equal to x times 12, which is 12x. And now I know to divide. Again, if you knew right away to divide, that is absolutely fine. You can go ahead and do that. Okay, so this would be 53.5 divided by 12, which is going to give me 4.46. We'll say hot dogs per minute. So he's eating approximately 4.5 hot dogs every minute, okay? And it says round to the nearest hundredth for my answer there, okay? All right, so here we go. We're solving a proportion. Now this time we have a little extra. We have this x plus 10 here. So I'm still going to do the same thing. When I see fractions equal to each other, I can do my butterfly method. 8 times 12 is 8 times 12 is 96. I want to make sure all my math is right here. And then we're going to do 1 times x plus 10. Now, obviously 1 times x plus 10 is 1. But if this had been like a 3 here, instead we would have had to distribute that 3 in before we added or subtracted. So make sure that if there's a different number besides 1 here that we do distribute it in. Obviously, if we distribute 1 in, that's just going to be the same thing. So we have 96 equals x plus 10. I'm going to subtract 10 from both sides. So I get x equals 86. Okay. And since there was no units on any of those, I can just leave it as 86. Okay. Go ahead and try this problem. I'll get it all in focus here. Okay, go ahead and try this problem on your own. It's very similar to the one we did in the first problem. So it says on a map, the distance from Chicago to Evanston is 0.625 inches. What is the actual distance if 1 inch is 18 miles? Is the scale factor. So on a map, every 1 inch equals 18 miles. So again, I can set up a proportion, and this one is my obvious fraction, right? 1 over 18. And it's 1 inch, so my inches go with inches, so I'm going to have 6.025 on the top here because, again, inches go with inches, over x feet, okay, or miles, I'm sorry, not feet. Okay, and we're going to go ahead and do our butterfly method. 1 times x is x, and 18 times 0.0625. 18 times 0.625, and obviously you can go ahead and use a calculator, that's what I'm doing off to the side here, is 11.25. And again, we want our proper unit here, so this would be miles. Okay, so in real life, Chicago and Evanston are 11.25 miles apart. Okay, I hope you have a wonderful day, and we'll talk to you later. Bye.